All right, hello guys, and welcome to another video. Okay, let's get into it. So, on this video, we'll be looking at energy, particularly kinetic, potential, and mechanical energy. All right, so here they say a skateboarder starting from the top of a ramp 4,5 above the ground skates down the ramp as shown in the diagram below. The mass of the skateboarder and his board is 65 kg. Ignore the effects of friction. Then they say define the term gravitational potential energy in weights. So this is going to be the definition. It's going to be that gravitational potential energy is the energy an object has because of its position in the gravitational field relative to some reference point. Okay, so I'm going to repeat it once more. Gravitational potential energy is the energy an object has because of its position in the gravitational field relative to some reference point. Okay, that is going to be your definition. All right, now we move on to the next one. Yeah, just pause guys if you didn't get the definition. Rewind and then pause the video to write it down. Then 5.2 says calculate the gravitational potential energy of the skater just before he skates down the ramp. So I always say that if you look at potential energy, it will normally have height. Okay, so if you have height, then you have potential energy. That's the best way to know how to calculate potential energy. And I say that if you have a height, it means you don't have kinetic energy. But as you skate down and you reach point X, it means you will lose your potential energy here because it will be zero, but gain your kinetic energy because when you get to this point, your velocity will increase. So this is the formula though for 5.2. We say that potential energy is EP is equal to mgh. But before we do the calculation, we need to write down our information. The M, guys, will stand for mass. And what is our mass in this case? It's 65 kg, right? That's our mass. Then we'll have our G. The G is a constant, and that is given on your constant uh, sheet, which is going to be meters per second squared. I mean 9,8 meters per second squared. Then we have our height. Our height in this case is going to be this 4,5 meters. So this is the information we have, and it will help us get our potential energy or gravitational potential energy. After writing down the formula and listing things down, or you can start by listing things down and then writing your formula, and then from there you will substitute these things. So we have m is our mass, which is 65. Then we have our g, which is 9,8. Then we have our height, which is 4,5, and then we just press the calculator to get the rest of the answer. Okay, so when I say 65 times 9,8 times 4,5, the value I get is 2,800 and 2,866,5 joules. That is the unit for energy, joules. So that's how you're gonna get your answer for 5.2. Okay, now let's look at 5.3. It says state the principle of conservation of mechanical energy in weights. It says that in an isolated system, the total mechanical energy before is equal to the total mechanical energy after all the total mechanical energy is conserved. Okay, let's just look at it from the exam guideline. So this is our let me just find it. Okay, all right, so this is the definition for the conservation of mechanical energy. Okay, so this is, you see here it says state the principle of conservation of mechanical energy. How do you state it? You say that the total mechanical energy in an isolated system is conserved or remains the same. Okay, you can say any of those two, or you can start with in an isolated system the total mechanical energy is constant or is conserved or remains constant. Okay, all right, that's how we will answer that question. So just write what I've highlighted in yellow basically. Okay, the total mechanical energy in an isolated system is constant or remains constant. Okay, let's move on to the next question now. The next question says, use the principle stated in question 5.3 to calculate the magnitude of the velocity of the skateboarder when he reaches the ground at point X. So we want the velocity when our skateboarder reaches here. How are we gonna do that? Let's see. So this is how we write the formula for mechanical energy. Obviously, they said we must use the principle stated up here, and that's the conservation of mechanical energy principle. So for 5.4, we will say there that EMAC, by the way, EMAC, mechanical energy, is the sum of what? Potential energy and kinetic energy. So we say before EMAC before is equal to EMAC after. That's how we'll do this calculation, and then we expand this formula to say mechanical energy. What is it? Mechanical energy is the sum of potential energy, which is mgh, plus kinetic energy, which is half mv squared. This is before, and then we go to the other side, we write the same thing to say mgh plus half mv squared. This is after. Okay, now that you've put this down, we move on to substituting. Okay, this is our information so far. Remember that we already had this mgh before. That was when the skateboarder was up here. So this is our before part, and this is our after part. Okay, when he's up here, that's before. When he gets down here, that's after. So before, the potential energy was this, guys. We had already found it, right? It was 2866.5. So that's what we're going to write here for mgh. We'll say 2800 and 2866.5 plus, here guys, at the top, that is before, right? We said at the top our velocity, the initial velocity, is going to be 0. So if the initial velocity is 0, it means here if we substitute by 0, everything here is going to be 0. Okay, everything here is going to be 0. So that means here I'm just gonna put 0. Then I go to the second part, which is the after part. That's here. Now here, guys, we say that if we move from the top of the ramp and get down here to position X, so as I go down and then I reach this point, I'm losing my height. And if I lose my height, it means that I will not have any height when I get to point X. My height will be 0 when I'm at point X. And if my height is 0 here, it means that if I put 0 here and multiply it with everything that's here, it's gonna make everything be 0. Okay, so if I say 65 times 9.8 times 0, everything here is going to be 0. So I'm gonna put 0 there plus, but when I get to this point, I'm gonna have an increased velocity, which will be my final velocity, but I don't know what it is. So that's what I'm looking for. Okay, I'm looking for the final velocity, which is this velocity. So I'm gonna have half in brackets 65, that's my mass, v squared, the v that I'm looking for now. Okay, then if I do my math, I'm gonna have 2866.5 is equal to, what is 65 divided by 2? It's 30. So that's half of 65. Is this correct? Let's see, 1/2 times 65, it's 32.5 actually, guys. So if I put this on the calculator as it is, I say half times 65, what I'm going to get is 32.5 comma 5 v squared. Then I divide by 32 comma 5 on both sides, 32 comma 5. But because my v which I want is squared, I'm just gonna square both sides because we know that these are going to cancel, right? So I remain with v squared, and because I want to remain with the v and get rid of this squared value, which is a 2, I'm just gonna square both sides. So that's what I'm gonna do. Therefore, v will be equal to, then I'm gonna take this whole thing as it is and put it on the calculator. So I'll say square root of what? Of 2866,5 divided by 32,5, and the answer I get is 9,39 meters per second. So this is my v basically. Okay, that's my answer for this question. I hope it makes sense, guys. I'm gonna erase it, so if you didn't if you didn't understand, just go back by rewinding the video and you will get everything you want. I'm gonna erase this part when I move on to the next question, 5.5. Okay, now we are looking at question 5.5, and it says, will the skateboarder be able to reach point Y if he were to remain on his skateboard? Write yes or no and support the answer with a relevant calculation. Okay, here guys, for us to answer this question, this is what we're going to do. There are two ways in which we can approach this question. Okay, the first way is to look for the height that the skateboarder will reach this side. Okay, and if that height is less than this 6 meters, it means that our skateboarder will not reach point Y. But if it's equal to 6 meters, it means that our skateboarder would then reach point Y. Okay, another way is to look for the mechanical energy before and compare it with the mechanical energy after. If the mechanical energy this side is not equal to the mechanical energy after, then it means that our skateboarder would not reach point Y. But I'm gonna use height for this question, and we are gonna look for our height. So we are gonna try find out what height will this skateboarder reach. Okay, and how are we going to do that? We are just gonna focus on this side, this ramp this time. This one we are no longer working with. Okay, this one is now out. Okay, we are focusing on this side. So if we are at point X, it means this is going to be our before, and going up is going to be our after. This side will be our after. Going up here, this will be our after. Okay, but remember, we don't know what the height is at the moment, so we don't know where the skateboarder will reach. That's what we're trying to find out with the calculation. So for this question, we are still going to use the principle of conservation of mechanical energy, right? And we know that it says that we are going to have the mechanical energy before, and that's half mv squared. Mechanical energy before is equal to the mechanical energy after, which is mgh plus half mv squared, and this is after. Okay, after. And then our mgh before, guys, before we are still here at point X, and that's on the ground. On the ground, we can see that our height is 0 there. We don't have any height. So if our height is 0, it means everything here is 0. Okay, because I'm gonna say 0 times this times that, and it gives me 0. So that's going to be 0 there. Then if I come to this side, initially, remember, when I got to this point, I got my final velocity, which was 9,3. Remember the velocity we got here, which was 9,39. But now this velocity becomes my initial velocity now. Okay, it changes to my initial velocity, because for me to get up there, I need to start with a certain velocity. So that means the velocity there before at this point X is 9,39. 39. So I'm gonna have half in brackets 65 multiplied by 9,39 squared is equal to, when I come this side, I'm looking for this height, right? I don't know my height in this case because I'm trying to find out what height will this skateboarder reach. So I'm gonna say 65 times 9,8 and multiplied by this height I'm looking for, plus, but I do know that whatever point I'm gonna reach will mean that my velocity, every time, guys, I'm up somewhere, my velocity becomes zero. My final velocity, or the velocity after, becomes zero in this case. Okay, so it means if my velocity is zero here, it means everything here will be zero, because it's gonna be half times 65 times 0 squared, which makes everything to be zero. When I'm at the top, I will not have any kinetic energy, or the kinetic energy will reduce to zero. Now you can see that I have this height, but if I'm calculating, I'm gonna start by putting all of this on the calculator, and it should give me this value. If I put all of this on the calculator, it's going to give me 2866,5 is equal to, this side I'm going to say 65 times 9,8, and the value I get is 637 multiplied by h. Because I'm looking for this h, I divide by the coefficient of h, which is 637. Then these cancel. Therefore, the height I'm looking for is going to be what? I'm gonna say 2866,5 divided by 637, and the value I get is 4,5 meters. Now, do you see that the height that we are getting here, which is 4,5, is less than this height? So it means our skateboarder will probably reach this point here. And if our skateboarder reaches here, it means they won't get to point Y. Why? Because the height we got here is less than the one that he's supposed to reach. So we'll say, therefore, the answer is, no, because our height is equal, which is equal to 4,5 meters, is less than the height he has to reach, which is 6 meters. Okay, thus you will not reach point Y. That is how we are gonna answer this question, guys. Okay, we move on now to the next one. I hope this made sense. See you on the next video though for the next one. I hope you enjoyed this one, and likewise, please guys, hit me with a like. If you have not subscribed, please just subscribe. See you on the next one.